All right, so yesterday we talked about completing the square, and every example we looked at was where a equals 1. Well, today we are going to look at ones where maybe a doesn't equal 1. So here's our first example, 2x squared plus 8x minus 14 equals 0. Now the way that we're going to do this is really similar to what we did yesterday. The first step is still to get our x squared plus x piece by itself. So the first thing I need to do is add 14 to both sides. I need to move it over to the other side. So I get 2x squared plus 8x equals 14. And now here's what's different from what we did yesterday. I cannot have that 2 in front of my x squared. So the way I can undo multiplying by 2 is to divide. But if I'm going to divide one term, in order to keep our equation balanced, we have to divide every term by 2. So that gives us x squared plus 4x equals 7. And again, you'll notice I'm leaving a little bit of space here so I have room to complete my square. But so we get this here, and you'll notice that everything divided by 2 really nicely. I will make sure that the problems you have all divide out nicely like that, because if they don't, eventually we'll want to use a different method. We haven't gotten there yet, but if they don't divide out nicely, completing the square would not be the way that you want to go. You'd want to use the quadratic formula instead. But for now, we are going to go with this. So remember that when I complete the square, the way we do that is we take half of b, which is 4. Half of b would be 2. And then I'm going to square that. So 2 squared is 4. So I'm going to add 4 here. Whatever I add to one side, I have to add to the other. Now, a lot of you are wanting to skip this part of adding the 4, but that 4 is really important. Otherwise, you can't factor it. We're setting this up so that it factors out to be a perfect square, x plus 2 squared. Without this 4 right here, it would not have factored to that. So you have to have it. And again, just a reminder that whatever this sign is here, that's going to be the sign that goes in between your x plus 2 in this case. That's why it's a plus instead of a minus. If that had been minus 4x, then you would have x minus 2 squared. And we get equals 11. And once we get to here, I now have a squared term all by itself, so I can square root both sides. A square root cancels a square, so I get x plus 2. And remember, the very next step after you've introduced a radical to your equation, that's where we're going to have plus or minus. So I get plus or minus 11. And then the very last step is to get x by itself, so I would do that by subtracting 2 from both sides. My final answer is x equals negative 2 plus or minus the square root of 11. All right. Let's do one more example on completing the square here. If you feel like you've got it, you can go ahead and move on to the next thing, but I'm going to show you one more just in case. So here is one more. 3x squared plus 12x equals 18. This one is kind of nice because the x squared plus x is already by itself. So that means we need to now get it down to just 1x squared. So what am I going to divide everything by? We are going to divide everything by 3. That takes care of that. So all we're going to have left is x squared plus 4x, leave yourself some space, equals 6. When I complete the square here, half of 4, this is exactly the same as the last one, half of 4 is 2, 2 squared is 4. So I'm going to add 4 to both sides, and now this factors to x plus 2 squared, and that's going to equal 10. The square root of both sides leaves me with x plus 2, and that equals plus or minus the square root of 10. The square root of 10 does not simplify, so we'll leave it just like that. And the last step would be to subtract 2 from both sides. That's why it's negative now. and I get 2 plus or minus the square root of 10. So again, this is very much the same as what we did yesterday. The only added step is this dividing by 3 step here. So that is completing the square when a is not equal to 1.